Hello everyone, hello my lovely students, it's Ms. Shabanu. This is our fifth PowerPoint lesson. I hope you're all doing very well. And as usual, I would like to give you some instructions about the video before we begin. This video includes the topics of Chapter 10 and a quick review of the chapter. In the exercises of the book, the problems are sorted into groups of the same style and method. One or two problems of each are solved. Anything written in light purple color should be copied into your math notebooks. The homework given should be written in math notebook. It's not a must to watch this video at once, so take your time, watch it within a few days, but understand the topics and do the requirements. Chapter 10, Lesson 4, Decimals. We have learned about decimals before. Decimals are in between numbers. They consist of two parts, the whole number part and the fractional part. These two parts are separated by a decimal point. The place of the digits to the right of the decimal point depends on the number of the digits that exist to the right of the decimal point. Remember this table from the previous lessons. If there is only one digit to the right of the decimal point, then the place of that digit is tenths. If there are two digits to the right of the decimal point, then the place of the last digit is hundredths. If there are three digits to the right of the decimal point, then the place of the last digit is thousands. Example given 1. The first number we have here is 3 3/10. That means we have 3 in the whole number part, and in the fractional part we have 3/10. What is 3/10? 3/10 means 3 parts out of 10 parts. Since we have only one digit to the right of the decimal point, then the place of this digit is tenths. That means this 3 is 3 parts out of 10 parts. The second one is 3 3/100ths, which means 3 is in the whole number part, and in the fractional part, we have 3 parts out of 100 parts. Since this 3 is the second digit to the right of the decimal point, it represents parts out of 100 parts. So here we have 3 parts out of 100 parts. That's why we read the number as 3 3/100ths. The third one is 3 3/1000ths, which means 3 is in the whole number part, and in the fractional part we have only 3 parts out of 1,000 parts. Why? Because this 3 is the third digit to the right of the decimal point, which means we have only 3 parts out of 1,000 parts, and that's why we read the number as 3 3/1000ths. Example given 2, writing decimals as mixed numbers. This boy's name is Lazo. Lazo is a very good boy. He's very smart. He tries to use everything that he learns in math in his daily life. For example, here his mother is trying to measure Lazo's height. So now we know that Lazo's height is 1 1/30 meters. So Lazo wants to practice his mathematics. He decides to write this number as a mixed number. So he writes 1 in the whole number part of the mixed number because 1 is written in the whole number part of the decimal. Then in the fractional part, he writes 30/100 because there are two digits to the right of the decimal point, 3 and 0. That means the place of the last digit is hundredths. So 30 parts out of 100 parts should be written as 30/100 in the fractional part of the mixed number, and that's why Lazo writes 1 30/100ths. So let's remember the places of these digits here in this number. The place of this 1 is ones, the place of the 3 is tenths, the place of the 0 is hundredths. So now, how many ones are in this number? Only 1. How many tenths are in this number? 3/10. How many hundredths are in this number? 0 hundredths. Why? Because the digit in the place of hundredths is 0. That's why we say 0. When a decimal is written as a mixed number, the fractional part of the mixed number should be simplified if it's not in the simplest form. Example given 3. 125 hundredths. So, if we want to write this number as a mixed number, 1 should be written in the whole number part because 1 is in the whole number part of the decimal. Then, since we have 25 hundredths, that means we have 25 parts out of 100 parts. The place of this 5 is hundredths, so the denominator of the fraction should be 100, and that's why we should write 1 and 25 hundredths. But remember, we said that we should simplify the fraction to its simplest form. So, is this fraction in its simplest form? It's obvious that it's not because they both have 5 as a common factor. You should know multiplication very well, and we have studied this before. So, factors of 25, 5 times 5 is 25. So, now we should find the factors of 100. But remember, we should write factors of 100 in a way that one of the factors is common with the above factors. So, remember 5 times 2 is 10. So 5 times 20 is 100. Now these two 5s are common, they cancel each other, the numerator and the denominator of the fraction as well, so only this 5 and this 20 are left for the fraction. But again, this fraction is not in the simplest form, we have to simplify it again. 5 times 1 is 5, 4 times 5 is 20. These two 5s take away each other, and the same thing for the numerator and the denominator of the fraction. So only 1 and 4 is left for the fraction, a quarter. So 1 and 25 hundredths written as a mixed number is 1 and a quarter. You don't have to write anything in these two slides, but you have to know them absolutely because they're very important and you will need them in solving many problems. These notes help you save time when you write decimals as mixed numbers. How? When you have a decimal number and it's required to write the decimal number as a mixed number, if the fractional part of the decimal number is 25. For example, here we have 2.25 or 2 and 25 hundredths. Then, the fractional part of the mixed number is always 1 over 4 or a quarter. And conversely, how? Here we have 2 and 25 hundredths. So, to write this number as a mixed number, you have to write 2 in the whole number part of the mixed number and 25 over 100 in the whole number part, in the fractional part of the mixed number. So, we said that we should simplify the fractional part of the mixed number. We did this in the previous slide. 5 times 5 is 25 and 5 times 20 is 100. So these two 5s take away each other and the numerator and the denominator of the fraction cancel one another as well. So only 5 and 20 is left. Again, we have to simplify this fraction. So 5 times 1 is 5 and 4 times 5 is 20. So these two 5s take away one another and the numerator and the denominator cancel each other as well. Here, only 1 over 4 is left. So you don't have to do this simplification every time. Whenever you see the fractional part of a decimal number is 25, when you convert this number to a mixed number, just write 1 over 4 in the fractional part of the mixed number and write the whole number as it is in the decimal. So 2 and 25 hundredths written as a mixed number is 2 and a quarter. Let me explain what a quarter means. If I divide a square into 4 equal parts, only one part is colored in white. That means 1 over 4 of the square is colored in white, or only 25 hundredths of the square is colored in white. And we usually say a quarter, not 1/4 or 1/4. We say a quarter. So whenever you see 1/4, say a quarter. A quarter. Number 2. If the fractional part of the decimal number is 5 or 50, then the fractional part of the mixed number is always 1/2 or a half, and conversely. How? For example, here we have 3.50 or 3 and 50 hundredths. So we have to write 3 in the whole number part of the mixed number and 50/100 in the fractional part of the mixed number. Now we have to simplify this fraction. So 5 times 10 is 50 and 10 times 10 is 100. These two tens take away each other. The numerator and the denominator cancel one another as well. So only 5 and 10 are left for the fraction. Again, we have to simplify this fraction. 5 times 1 is 5. 2 times 5 is 10. These two 5s take away each other, so only 1/2 is left. So you don't have to do this simplification every time. Whenever you see 50, just write 1/2 in the fractional part of the mixed number as it's shown here. So 3 and 50 hundredths written as a mixed number is 3.5. Another example, here we have 5 in the fractional part of the decimal, so that means we have 4 and 5/10. We have to simplify this fraction. 1 times 5 is 5 and 2 times 5 is 10. These two 5s take away each other, the numerator and the denominator as well, so only 1/2 is left. So you don't need to do this simplification. Just write 1/2 in the fractional part of the mixed number and keep the whole number as it is. So 4 and 5/10 written as a mixed number is 4.5. So let's clarify that half more. If I have a square and divide the square into 4 equal parts or 2 equal parts. So here 2 parts are colored in white out of 4 parts, or 1 part is completely colored in white out of 2 parts. That means half of the square is colored in white. So that's why we call 1/2 half. So here we usually say 4.5. When a decimal is written as a mixed number, if the fractional part of the decimal is 75, then the fractional part of the mixed number is always 3/4, and conversely. Let me explain. If I have a square, 3 parts of the square out of 4 parts are colored in white. So that means 3/4 or 3/4 of the square is colored in white. Or I can say 75 hundredths of the square is colored in white. So whenever you see 3/4, you should say 3/4. That means 1/4, 2/4, 3/4 of the square are colored in white. Now let's clarify this more by an example. We have a decimal. The fractional part is 75. That means we have 75 parts out of 100 part. So we write 75/100 in the fractional part, and we keep the whole number as it is in the whole number part. So we write 5 and 75 hundredths. Now we have to simplify this fraction to its simplest form. 75/100. Factors of 75 are 5 and 15. 5 times 15 is 75. You can do it by division. We have done this before. And what about 100? 5 times 20 is 100. So these two 5s cancel one another, and the numerator and the denominator of the fraction as well. So only 15 and 20 are left for the fraction. Again, we have to simplify this fraction. 3 times 5 is 15, 4 times 5 is 20. So the 5s cancel one another again, and we will get 3/4 or 3/4 as the fraction in its simplest form. So whenever you see 75 in the fractional part of the decimal, write 3/4 or 3/4 in the fractional part of the mixed number. You don't have to do this simplification every time. Just write 3/4. Decimals on the numbered line. Example given 4. So we will understand how a quarter and 0.25 are equal. Here we have a numbered line. The numbered line shows a unit between 8 and 9. The unit is divided into 4 equal parts, or we can say the unit is divided into 4 quarters. Now, from 8 till the first subunit is 1 quarter. So here we have 8 and a quarter, and as a decimal we have 8 and 25 hundredths. That means they both lie on the same position, so they're equal. So whenever you see 25 in the fractional part of a decimal, write 1/4 in the fractional part of the mixed number. You don't have to simplify 25/100 every time. Here, till the middle, we have 8 and 50 hundredths. That means half of the way. We have 50 parts out of 100 parts. We have 1 part out of 2 parts. So that's why we say 8.5 or 8 and 50 hundredths. The mixed number form of this decimal is 8.5. Till here we have 3 quarters out of 4 quarters, so that's why we say 8 and 3/4 or 8 and 75 hundredths. So whenever you see 75 in the fractional part of a decimal, write 3/4 in the fractional part of the mixed number. Writing mixed numbers as decimals. Example given 5, 1 and 3 hundredths. So in the whole number part, we have 1. So in the whole number part of the decimal, we should write 1. But in the fractional part, we have 3 parts out of 100 parts. Since we have parts of 100, that means we should have 2 digits to the right of the decimal point. But as the numerator of the fraction, we have only 1 digit. So we should write only 1 0 before the 3 and to the right of the decimal point. So write 1.03 or 1 3 hundredths. Example given 6. Here we have 3 and 1/5. So how can I write this number as a decimal? We are used to parts of tens, hundreds, and thousands, but here we have parts of 5. We can use equivalent fractions to solve this problem. How? We know how to write mixed numbers as decimals if the fractional part shows parts of 10, 100, or 1,000. But here we have parts of 5. So what we have to do is to find an equivalent fraction by this fraction. We should change this 5 to 10. So if we have 5, we will change it to 10. If we have 50, we will change it to 100. If we have 25 as the denominator, we will change it to 100 by multiplying the 25 by 4. So here we have 5. We have to multiply both the numerator and the denominator by 2. So 1 times 2 is 2. 5 times 2 is 10. So we have an equivalent fraction for this fraction. Now we can write the mixed number as 3 and 2/10. It's very easy now to write this number as a decimal. So we have 3 in the whole number part and 2 in the fractional part because we have 2 parts out of 10 parts. Remember, we should have parts of tenths, hundredths, or thousands to write the mixed number as a decimal. Equivalent fractions can be used to write the mixed number as a decimal. When the denominator is 5 or 50, make an equivalent fraction by multiplying both the numerator and the denominator by 2. If the denominator is 25, make the equivalent fraction by multiplying both the numerator and the denominator by 4 as number 6 in page 200. Exercise page 191. Write a decimal and a mixed number for each, then write the word form. Number 1. We have models again. So we have to understand what do these models mean first. We have squares. The squares are divided into 10 equal parts. So we have two squares that are completely colored in purple. But the third square, only 3 parts out of 10 parts of the square is colored. So what does it mean? That means 2 and 3/10, because we have two complete squares colored in purple and only 3 parts out of 10 parts in the third square colored in purple. So the mixed number is written this way, 2 and 3/10, and this is how the decimal is written. The word form is 2 and 3/10. This is the word form. Number 3. Again we have models. We have two squares. The squares here are divided into 100 smaller squares. One of the squares is completely colored, so we have one entire square colored in purple. But the second one, only 5 small squares out of 100 squares are colored in the entire square. So how can I represent this amount in a mixed number or a decimal? In the whole number part of the mixed number, we should write 1 since we have one whole square colored. What about the fractional part? We should write 5 over 100 because we have only 5 smaller squares colored out of 100 smaller squares, and that's why we wrote 5 over 100, and the number is read as 1 and 5/100ths. In the decimal form, the same thing. The decimal number, the same thing. We have 1 in the whole number part and 0.5 in the fractional part. Why? Since this part or this square shows parts of 100, then we have to write 2 digits to the right of the decimal point. But we have only 5 parts colored out of 100 parts, so we should write 0 then the 5, because this 5 should have place of hundredths because it represents 5 parts out of 100 parts. Exercise page 191. Write an equivalent mixed number or a decimal. Number 5, 11 and 50/100ths. It's very easy. First, we have to write 11 in the whole number part of the mixed number. Then, in the fractional part, we will write 50 over 100 because we said 50/100ths. That means 50 parts out of 100 parts. Remember, we said that the fraction should be simplified in the fractional part of a mixed number. You don't have to do the simplification every time. We know that when we have 50 in the fractional part of the decimal, the fractional part in the mixed number will be 1 over 2. So the mixed number is 11.5. Number 6, we have 9.25. Remember the notes. We have 9.25, so that quarter means 25 in the fractional part of the decimal number. So write 9 in the whole number part of the decimal, then 25 in the fractional part of the decimal. This can be done in several ways, but the easiest one for you is this way. You should know that 1 over 4 is equal to 0.25 and 0.25 is equal to 1 over 4. Remember, those notes are very important. Number 7, we have 7 and 25/100ths, the same. So write 7 in the whole number part, since we have 25 in the fractional part of the decimal, so the fractional part of the mixed number is a quarter, 7.25. Number 8, 4 and 1/5. So we said that we are used to parts of tens, hundreds, and thousands, but here we have parts of 5. So how can we write this mixed number as a decimal? By using equivalence. Remember, it's very easy to change 5 to 10. Just multiply it by 2. So multiply both the 5 and the 1 by 2. 1 times 2, 2. 5 times 2 is 10. So now we have 4 and 2/10. We have an equivalent fraction. This fraction is very easy to be changed to decimal. How? Write the 4 in the whole number part. We have 2/10. Then write 2/10. Only 2 to the right of the decimal point. Here, if this was 50, again multiply it by 2. If this was 25, we should have multiplied the 25 by 4 to change it to 100. Here we have 5, so it's very easy. Change it to 10. Use the number line to write a mixed number or a decimal for each letter. We have a number line. The number line shows from 4 to 6, and each unit is divided into 4 subunits. So we have 4, 4 and a quarter, 4 and 50 hundredths, 4 and 3/4, 5, 5 and a quarter, 5 and 50 hundredths, 5 and 3/4, 6. Number 14 asks for B. Where's letter B? This is letter B. So what comes after 4 and a quarter? Remember here they are equal. So we said if we have 50 in the fractional form of a decimal, then the fractional form of the mixed number is 1/2 or and a half. So it must be 4.5. Number 16, letter D. This is D. We have 5 and 3/4. So 5 and 3/4 is equal to 75. Remember the notes that I told you. So we should write here 5 and 75 hundredths. Homework page 191, number 2, 4, 10, 12, 13, and 15. Chapter 10, Lesson 5, Equivalent Decimals. Lesson 5, Equivalent Decimals, page 192 to 193. This subject is very easy, so pay attention. It takes 5 minutes to understand everything. Equivalent decimals are numbers that represent the same amount. How? We have example given 1. Remember that we studied equivalent fractions. It's similar to that subject. We have 2 squares. The first square is divided into 100 equal parts, and the second square is divided into 10 equal parts. In the first square, 50 parts out of 100 parts are colored. In the second square, 5 parts out of 10 parts are colored in purple. So, how are these two decimals equivalent? Now, if we pay attention, in both of the squares, half of each square is colored in purple. Look, the first one, this is half of the square colored. The second one, the same thing. Yeah, here we said 5 parts out of 10 parts, and here we said 50 parts out of 100 parts, but both of them make up the same amount of each square. So that's how decimals can be equivalent. So this 0 doesn't change the amount. Yes, it says 50 parts out of 100 parts, but it still makes the same amount as the 5/10. Exercise page 192 to 193. Number 1. Explain how you can tell if the numbers 1 and 8/10 and 1 and 80 hundredths are equivalent. Since they both represent the same amount, so they're equivalent, just like the example I gave you before. Are the two decimals equivalent? Write yes or no. Number 2, 5/10 and 50/10. Yes, they both represent the same amount as example given 1. In other means, here we have 5 and here the same 5. So this 0 doesn't change anything after this 5. So yes, they are equivalent. Number 3. Here we have 4 hundredths and here we have 40 hundredths. Are these two equivalent? No, because here we have 4 parts out of 100 part, but here we have 40 parts out of 100 parts. So this is much greater than this one. So we can't say that they are equivalent. No, they are not. Number 4. We have 7/10ths and 7/100ths. Are they equivalent? No. Why? Because this one shows 7 parts out of 10 parts. Be careful. Here, this represents 7 parts, only 7 parts out of 100 parts. So this is not equivalent to this one. So we can't say that these two numbers are equivalent. So the answer is no. Number 6. 80 hundredths and 8 hundredths. Are these two equivalent? No. Why? Because here we have 8 parts out of 100 parts, but here we have 80 parts out of 100 parts. Number 7. We have 9/10ths and 95 hundredths. Are these two equivalent? No. Why? Because here we have 5 hundredths. So this number is greater than this number by 5 hundredths. So we can't say that these two numbers are equivalent. Number 9. 2 and 30 hundredths with 2 and 3/10ths. Are these two numbers equivalent? Yes. How? They both have equal amount of whole number part, 2. When we come to the fractional part, look, this is 3 parts out of 10 parts. This is 30 parts out of 100 parts. So 30 out of 100 and 3 out of 10 are the same. So yes, they are equivalent. Number 10. We have 9/10ths and 1/9. Are these two numbers equivalent? Absolutely no. Why? This one is much greater than this number, because here we have 1 in the whole number part, but here we have 0. So how can they be equivalent? They are not equivalent. Write an equivalent decimal for each number. We have 10 hundredths. So just adding one more 0, it doesn't change anything. It's the same as 10 hundredths. So 100 thousandths is the same as 10 hundredths. Number 16, here we have 2 and 4/10ths. So just add one more 0 to the 4, it becomes 2 and 40 hundredths. They represent the same amount. Number 18, reasoning. Soranu's father plants 50 hundredths of his garden with flowers and 5/10ths with vegetables. Are there enough room to plant potatoes? So let's imagine together this square is the garden. Here it says 50 hundredths of the garden is planted with flowers. So imagine this side is the flowers. Remember, I told you that 50 hundredths is the same as 5/10ths. And they both represent half of something. So here, half of the garden is planted with flowers and the other half is planted with vegetables. So the entire garden now is planted with vegetables and flowers. So there isn't enough room to plant potatoes. Remember, there's a very important note that you should always remember in equivalent decimals. Adding zeros after the last digit in the fractional part of a decimal number doesn't change the amount, just like this 50 hundredths and this 5/10ths. If I make this 500 thousandths, it still doesn't change anything because it's still the same as half of the garden. The amount doesn't change. So if this is 50 here and this is 5, The difference is 1 0 at the end, so it doesn't change the amount. Therefore, the answer is no, there isn't enough room to plant potatoes. 50 hundredths and 5 tenths are equivalent decimals since they both represent the same amount, a half. That means the entire garden is planted and there isn't any room left to plant potatoes. Homework page 193, number 5, 8, 13, and 15. Chapter 10, Lesson 6, Compare and Order Decimals. Lesson 6, Compare and Order Decimals, page 194 to 197. A. Comparing decimals. Decimals can be compared in two ways, using number lines and place value. Comparing decimals using number line. On a numbered line, the numbers to the right are greater than the numbers to the left. We have studied this in the beginning of the year. It's very easy. Example given 1. We have these two boys. This is Mandy, this is Cesar. They're all the time competing about their heights. Mandy is saying, I'm taller than you. Cesar saying, no, I'm taller than you, because they don't know about decimals. So, we should compare their heights by using number line to know which one of them is taller. So Mandy's height is 1 47 meters and Cesar's height is 1 29 meters. So here, this is 1 1/10, 1 2 tenths, 1 3 tenths, 1 4 tenths, 1 5 tenths. Mandy's height is 1 47 hundredths. 1 47 hundredths. So this must be somewhere between 1 4 tenths and 1 5 tenths, right? Because this 1 5 tenths is the same as 1 50 hundredths. I told you we can add a 0 here. It doesn't change the value. So if this is 1 4 tenths, then this is 1 41 hundredths, 1 42 hundredths, 1 43 hundredths, 1 44 hundredths, 1 45 hundredths, 1 46 hundredths, 1 47 hundredths. So here's the position of Mandy's height. What about Cesar? Cesar's height is 1 29 hundredths. So 29 must be between 1 2 tenths and 1 3 tenths. This is 1 2 tenths. So this must be 1 21 hundredths, 1 22 hundredths, 1 23 hundredths, 1 24 hundredths, 1 25 hundredths, 1 26 hundredths, 1 27 hundredths, 1 28 hundredths, and finally here's 1 29 hundredths. So this is the position of Cesar's height on the number line. Now, which one is on the right? 1 47 hundredths. That means Mandy is taller than Cesar. 1 47 hundredths is to the right on the number line, so Mandy is taller than Cesar. Number 2, comparing decimals using place value. This one is very easy. First, line up the decimal points, then compare the digits beginning with the greatest place value, which means from the left to the right. Example given 1. We have 1 and 222 thousandths and 1 and 22 hundredths. So let's line up their decimal points. I made this table. It's very easy. Now we have place of ones, the decimal point, tenths, hundredths, and thousandths. So here I wrote the decimal points, here the ones, and the other digits are written here. Now, if I compare their ones, it's because it says start comparing with the greatest place value. So the greatest place value is ones. They're equal. They both have 1 in their ones. So we have to go to the other place, which is tenths. Again, we have 2 in tenths in both of the decimals. So 2 is equal to 2. We have to move to the next place, hundredths. Again, the same thing. We have 2 hundredths in both of the decimals. So they're equal here too. We have to move to the next place, which is place of thousands. In the first number, we have 2 thousandths, but in the second number, there isn't any thousands. It's like, we can say it's 0. So 2 is greater than 0. Therefore, 1 and 222 thousandths is greater than 1 and 22 hundredths. B. Order in decimals. Decimals can be ordered in 2 ways, using number line and place value. Number 1. Order in decimals using number line. On a number line, the numbers to the right are greater than the numbers to the left. Example given 1. We have 3 students, Donna, Bob, and Chris. We have to order their names according to their heights, from tallest to shortest, which means from greatest to least. So now we have to place each height on the number line, then order them. We will start from Donna. Donna's height is 1 and 42 hundredths meters. So this is 100 and this is 1 and 40 hundredths or 1 and 4 tenths. So this must be 1 and 41 hundredths, 1 and 42 hundredths. So here's the place of Donna's height. Then we have Bob. Bob's height is 1 and 15 hundredths meters. This is 1 and 1 tenth. This is 1 and 2 tenths. So this must be somewhere between them. So let's start counting them. This is 1 and 1 tenth, 1 and 11 hundredths, 1 and 12 hundredths, 1 and 13 hundredths, 1 and 14 hundredths, 1 and 15 hundredths. So this is the position of Bob's height on the number line. What about Chris? Chris's height is 1 and 35 hundredths. So it must be somewhere between 1 and 40 hundredths and 1 and 30 hundredths. If this is 1 and 3 tenths, this is 1 and 31 hundredths, 1 and 32 hundredths, 1 and 33 hundredths, 1 and 34 hundredths, 1 and 35 hundredths. So this is the position of Chris's height on the number line. Now, we said that the numbers to the right are greater. That means 1 and 42 hundredths is greater than 1 and 35 hundredths, and 1 and 35 hundredths is greater than 1 and 15 hundredths, just as written here. That means Donna is taller than Chris, and Chris is taller than Bob. Number 2, order in decimals using place value. Line up the decimal points, compare the digits beginning with the greatest place value from the left to the right. Example given 1. Order the followings from greatest to least. 5 tenths, 5 hundredths, and 55 hundredths. First, I lined up the decimal points as it's shown here. Then I started comparing from the greatest place, or from the left to the right. So here, in the first place, they have the same digit. 0 is equal to 0. So I have to move to the second place, which is place of tenths. Here we have 5 and 0. We all know that 5 is greater than 0. So the number which has 0 in its first digit to the right, as its first digit to the right of the decimal point, is the least. So now we know that 5 hundredths is the least among them. Now we have to compare the numbers that are left to find the greatest one, because it asks for the greatest to least. Now, I'm comparing 5 tenths and 55 hundredths. and I'm comparing the place of hundredths. In the above number, I don't have any digit in place of hundredths, which means it's 0. So 5 is greater than 0, therefore 55 hundredths is the greatest. And this is how I order the numbers. 55 hundredths is greater than 5 tenths, and 5 tenths is greater than 5 hundredths. Exercise page 196 to 197. Number 1. Tell how you can use a number line to help you compare decimals. It's very easy. On a number line, the numbers to the right are greater than the numbers to the left. So after we place them on the number line, the numbers that are on the right or to the right are always greater than the numbers to the left. Compare right symbol less than, greater than, and equal for each. Number 2. 45 hundredths and 35 hundredths. So let's start comparing from the left to the right. 0, 0, they are the same. So let's go to the next place. 4, 3. 4 is greater than 3, so 45 hundredths is greater. Number 4. 3 hundredths and 30 hundredths. 0, 0, when we start comparing from the first place to the left, or the greatest place, they are equal. So we have to move to the second one, which is place of tenths. Here we have 0, but here we have 3. So 3 is greater than 0. That means 30 hundredths is greater than 3 hundredths. Number 5. 7 and 50 hundredths and 7 and 5 tenths. Here we have 7 and 7 equal. 5 and 5 equal. 0 and nothing, which means also 0, equal. So these two numbers are equal. Number 6. 5 and 4 tenths with 5 and 243 thousandths. So let's start comparing. 5, 5 equal. Let's go to the next place. 4 and 2. 4 is greater than 2. That means 5 and 4 tenths is greater than 5 and 243 thousandths. Use the number line to order the decimals from least to greatest. From least to greatest. Number 8. We have 2 and 1 hundredths. We have 2 and 10 hundredths. We have 2 and 2 tenths. We have 2 and 2 hundredths. So let's place them on this number line. First, start from 2 and 1 hundredths. It must be between 2 and 1 tenth. This is 2 and 1 tenth. This is 2. So this must be 2 and 1 hundredths. So this is the place of 2 and 1 hundredths. The second number is 2 and 10 hundredths. This is 2 and 1 tenth. It's the same as 2 and 10 hundredths. As I told you, this 0 doesn't change the amount. So they are equivalent. And this is the position of 2 and 10 hundredths. The third one is 2 and 2 tenths. So here we have 2 and 2 tenths. It's obvious. This is the place of 2 and 2 tenths. The last one is 2 and 2 hundredths. Like in 100 parts, we have only 2 parts. So this is 2, and this is 2 and 1 tenth. Therefore, this is 2 and 1 hundredths. This is 2 and 2 hundredths. This is the position of 2 and 2 hundredths. Therefore, if we want to order the numbers from least to greatest, we should start from the number which is to the left, then go to the right. So we should start from 2 and 1 tenth, 2 and 1 hundredth, 2 and 2 hundredths, 2 and 10 hundredths, 2 and 2 tenths. So that means 2 and 1 hundredths is less than 2 and 2 hundredths. 2 and 2 hundredths is less than 2 and 10 hundredths. And finally, 2 and 10 hundredths is less than 2 and 2 tenths. So 2 and 2 tenths is the greatest. Use the number line above to order the decimals from greatest to least. Number 11. We have 2 and 94 hundredths, 2 and 49 hundredths, 2 and 4 tenths with 3. It says order them from greatest to least using the number line above. So let's mark each number on the number line. And we will start from 2 and 94 hundredths. So this is 2 and 9 tenths. If we want to make this, divide this into smaller parts, then this becomes 2 and 91 hundredths, 2 and 92 hundredths, 2 and 93 hundredths, 2 and 94 hundredths. This is 2 and 94 hundredths. Then we have 2 and 49 hundredths. This is 2 and 4 tenths. This is 2 and 5 tenths. So 41, 42, 43. This is 2 and 49 hundredths. The third one is 2 and 4 tenths. So this is 2 and 4 tenths. It's already marked. What about 3? This is 3. It says from greatest to least. Then the numbers to the right are greater than the numbers to the left. So 3 is greater than 2 and 94 hundredths. And 2 and 94 hundredths is greater than 2 and 49 hundredths, which is greater than 2 and 4 tenths. Order the decimals from least to greatest. We have 96 hundredths, 1 and 6 hundredths, 9 tenths, and 1 and 6 tenths. We have to order these numbers, so first we should line up their decimal points and start comparing from the greatest place. So in the first place, they have 0 and 1. We all know that 0 is less than 1. So the numbers starting with 0 are less. We should start comparing these two. We have 96 hundredths and 9 tenths. So their first place is the same. Let's go to the second place. They are still the same. But here in the third place, which is place of hundredths, here we have 6, but here we don't have any digit in place of hundredths, which means 0. So 0 is less than 6. Therefore, 9 tenths is the least decimal. Now, we know that we still have two numbers that we should compare to know which one is greatest. Now, we have 1 and 6 hundredths with 1 and 6 tenths. Their first place are equal, so we move to the second one. 0 is less than 6. Therefore, 1 and 6 hundredths is less than 1 and 6 tenths. So 1 and 6 tenths is the greatest. Now, if we order the numbers from least to greatest, we say that 9 tenths less than 96 hundredths less than 1 and 6 hundredths less than 1 and 6 tenths. Number 16, reasoning. Which of these decimals have the same value as the digit 7 in 136 and 74 thousandths, 77, 7 tenths, 7 hundredths, or 7 thousandths? Remember how I told you to find value of digits in numbers. Here we have the 7 in place of hundredths. So I told you when you try to find the value of a digit in a decimal, ignore all the digits to its right and change all the digits to its left to 0. So here, ignore this 4. Now we have the 7 itself. We have one digit before it, which is already 0, so write that 0 too. Then we have the decimal point. Consider the whole number part as 0, so write 0 for it. Therefore, 7 hundredths is the decimal that has the same value as the digit 7 in this number. For questions 20 to 22, use the table. Kilometers runner Twana Hiwa Dilir, time in minutes 6 and 50 hundredths, 6 and 45 hundredths, 6 and 40 hundredths. Number 20. What was the time for the fastest runner? Since it says the fastest runner, it means that person should have finished the run in the shortest time or in the least time, during the least time. So which one is the least? It's very easy. They are the same. This is greater, so of course it's not this one. These two are the same too. If we compare these, 0 is less than 5, so this one is the least. So 6 and 40 minutes, 6 and 40 hundredths minutes is the time for the fastest runner. Number 21, KV also ran in this race. His time was 6 and 48 hundredths minutes. Order the times from least to greatest. It's already ordered, but if we add this time, it's very easy. This 48 is between the 50 and the 45, so since it says from least to greatest, start from 6 and 40 hundredths less than 6 and 45 hundredths less than 6 and 48 hundredths less than 6 and 50 hundredths. Number 22, who was faster, KV or Hiwa? Since Hiwa finished the run in a shorter time than KV, so he was faster. Homework page 196 to 197, number 3, 7, 10, 12, and 15. By now, we have finished chapter 10. Before we start studying any new chapter, we used to have a quick review of the previous chapter. So, let's have a quick review of chapter 10. Number 1. A number with one or more digits to the right of the decimal point is a decimal. Number 2. Decimals that name the same number are equivalent decimals. Write each fraction as a decimal. Number 5. 2/5. We have to change that 5 to 10. Remember, I told you that by using equivalent fractions. So 5 multiplied by 2 is 10. 2 times 2 is 4. 5 times 2 is 10. Now we have 4/10. It's very easy to change 4/10 to a decimal. We have 0 in the whole number part and we have 4/10 in the fractional part. Number 6. We have 9/25. Remember, I told you about this question in the previous slides and I gave you a note. I told you if you have 25 as the denominator, multiply it by 4 to change it to 100. So 9 times 4 is 36. 25 times 4 is 100. 36/100. We have 0 in the whole number part, so write 0 here. We have 36 hundredths, so just write 36. Number 8, we have 176/100. First of all, this is an improper fraction. We have to change it to proper fraction by division. There are several ways to do this, but in the previous lessons, I told you to do it by long division. So, if you divide 176 by 100, you will get 1 as the quotient and 76 as the remainder. So, it becomes 1 and 76 hundredths. So we have 1 in the whole number part and 76 hundredths in the fractional part. Since the denominator is 100, then that means the fractional part of the decimal number is also in place of hundredths. We have 2 digits at the top, so we don't have any problem. The number is 1 and 76 hundredths. Write an equivalent decimal for each. It's very easy, just add 1 0. We have 60 hundredths, make it 600 thousandths. We have 4/10, make it 40 hundredths. That's it. Write each number as a mixed number or as a decimal. Number 13, 6 and 97 thousandths. So we have 6 in the whole number part. In the fractional part, we have 97 parts out of 1,000 part. That means we should have 3 digits to the right of the decimal point. Since the numerator is 97, so write the 97, then add 1 0 before the 97 or to the left of the 97 to make it 3 digits to have place of thousands. Now we have 6 and 97 thousandths. Number 14, we have 4 and 2 thousandths. That means we have 4 in the whole number part and we have 2 out of 1,000 parts, since we have 3 digits to the right of the decimal point. So write 2 over 1,000. Order the decimals from least to greatest. We have 3.06, 3.97, 3.614, 3.8, or you can say 3 and 600ths, 3 and 9 700ths, 3 and 614 thousandths, and 3 and 8 tenths. We have to order these numbers from least to greatest. So start comparing from the first place. They're all or equal, so it doesn't change. We have to compare the second place. Here we have 0, 9, 6, 8. So the 0 is the least. Write it first. Now we have these three numbers. We have 9, 6, 8. So 6 is less than them all. So write the 6. Again, we have these two. We have 9 and 8. So write 8 first and then the 97 hundredths. So 3 and 6 hundredths is less than 3 and 614 thousandths, less than 3 and 8 tenths, less than 3 and 97 hundredths. Remember, these problems are all from page 200. By now, we have finished our 5th PowerPoint lesson and chapter 10. I love you all and I miss you so much. By the way, don't think that I forgot about the clip. I'm working on it. Thanks for watching.